Good day, Professor Breaker here with New Mexico State University. In this video, we're going to review Chapter 2 in the Python Crash Course textbook. This is for the ICT 362 course with New Mexico State University's ICT program. The first thing we're going to talk about, the topics covered in Chapter 2 are basically Python variables, naming them, assigning string values to them, using string variable functions. We're going to talk about variable types, strings, integer, floats. I also added Boolean. It's not covered in the chapter, but I want to make sure that was available and you're aware of it. And we're going to talk about constant variables and commenting code. So, naming variables. Three things: the do's, the don'ts, and things you should avoid. The do's, you can use letters like A through Z, uppercase or lowercase. You can use numbers 0 through 9 like L0L, that would be fine, but do not start the variable with 01 or 0IL, that will not work. You can use underscores. You can use it for starting a variable name like aardvark, underscore aardvark, mountain underscore lion. It's oftentimes used to help define what a variable value should be associated with. And then you could use underscore 3 children. That would work because you're starting with the underscore and not the 3. Don't use keywords like print. Don't use white spaces or any white space. Avoid letters that could be mistaken. For instance, if you started a variable and you called it last name with a lowercase l, that would make sense. People would understand it's probably a lowercase l. If you started with an IAST name, that would really throw people off and could create errors in your code later. You can see from this, just the way it's put out here in this font, the L and the I look almost identical. One's a little smaller than the other, but you wouldn't notice that. And other fonts used in text fonts, it may not be much of a difference. Even the one sometimes can be very similar to the I or the uppercase I or the lowercase l. Uppercase O and 0, again, here you can see there's clearly a difference in this font, but it's not always clear in some other fonts used, especially in text editors. Assigning a string variable is real simple. You just give it a name and you use the assignment operator. The assignment operator is an equal sign. Again, these are called operators. Now, if we wanted to look at a comparison operator, does variable name equal string value? Then you would use the double equal sign. That would be a comparison operator. This is an assignment operator. And again, these are terms used in programming, coding all over, whether you're talking Java, C programming, or Python. This is a statement. This is another statement. This is an assignment operator. It's assigning a value to a variable. This is another assignment operator. It's assigning two values to two variables. We can look at string variable functions. These are the ones that are talked about in the book. And so basically here's our two variables. We can go variable name.title. That makes it title case, which means the first letter of every word would be uppercase. So in this case, we uppercase string, uppercase value. Okay. We could say variable the string, as long as this is a string, .upper, it would uppercase it, make everything uppercase. This would make everything lowercase. Variable name.sort will not sort the characters. And so I'm going to give you a little teaser for the next chapter. In the next chapter, we're going to be talking about lists, which is similar to what you would look at in arrays in Java. So strings are treated as a list of characters, an array of characters in Python. However, it's a unique list. And not all list functions work on strings, like the sort function. And not all string functions work on lists. Let's take a little example of that. So I've created a string here called string value, and I've created a list, apple, oranges, lemons. Again, teaser for next week, our next chapter. If I do a string, and I can treat it like a list, and I'm going to pull a value out of it. I can do that, and it's going to bring the first character out of the string. So it's an uppercase S. You can see that right there. And if I did the same thing with the list, and I'm going to pull the first value out of the list. In this case, I'm pulling out apples. Okay. If I want to pull out a range, I can do string A, and I can start with 0 and go to 5. It'll pull out the first 5 parts characters. Again, it treats it like a character array. It pulls out the first 5 characters, so it treats it very much like a list. And then since there's not 5 here, let's do our list. And let's go 0 and 2. Oops, I forgot the bracket here. And it'll give us the first 2. If I do the string, done. Oh, doesn't like it. There's no attribute sort because now it's recognizing it as a string, not a list. And if I do list, now it's going to sort them. So now if I do list B, it's sorted them. It was apples, oranges, lemons. Now it's apples, lemons, oranges. And so it actually changed the values in the list. Whereas if you use the string functions, let's use the string function here, string dot title. It's already a title case, but it's gonna, it looks the same. Let's do string dot upper. Okay, so there's our output string value, but if I just do string A, it doesn't change the actual value of the variable. The value is the same. It just displays it as uppercase. It displays it as lowercase, or it'll display it as a title case. But it doesn't change the actual variable. Where on a list, if you applied the function like sort, it actually changes the variable. When I say list B, it actually changes and execute that on the variable itself. So just a heads up on that. There's a little bit of a difference between strings and lists because of the type of object that they are. One is a string object, the other one is a list object. But there are a lot of similarities. All right, let's go back to our lecture here. Let's talk about concatenating. Basically, the book uses the newer format method with the F, and you basically put the F in front, put your brackets, and then put your variables inside the brackets. Again, there you have a space here to give a space between the first variable and the second variable, and then again the second variable. They talked about the dot format method. Again, this works with Python 3.6 and newer. The old format method worked with any version 3 previous to 3.6. It worked basically with all the other rest of the 3.0 versions. So you'd have the 2 brackets. Again, you're adding a space in here, and then you say format, and you pass it the variables in the format statement, and it'll put out the same thing. There's other methods to concatenate strings. You can just use the plus operator. Okay, again, this is an operator. So you're using first plus space plus last. And it's going to treat them as 3 strings and puts them together. There's other substitutions, and this one should be similar to those people that have worked with the formatting, string formatting in Java, where you use the %s. It's a little bit different, but it's still similar. It's doing the % sign here, and then you pass it the variables. And you can do a %s or %d for decimal, or %f and tell how many float spaces. So you can still do the old-fashioned substitution like this. This also, all 4 of these are different methods of formatting and outputting concatenate multiple strings in a sentence, or assigning values of multiple strings in a specific format. So that's covered pretty well. White space is basically a space is a white space. A tab is a white space, and a new line character is a white space. And there, oftentimes you'll want to use these. So you're assigning strings, and you want to put it out really nice, the printout to look nice. You can actually put it in right in your variables, add your spaces, and here again you see the new line character, the tabs, and so here's the output when I print it out. It looks really nice, well aligned with the tabs. And you can do right tabs and center tabs and things like that. So you have your tabs. Another one would be example. For instance, you're using code to build a web page. You've queried a database. You're pulling information out of the database. You're putting it in a table in a web page. You basically can throw in the formatting for new lines and tabs and things like that to make your output of your web page, the actual text, look nice. Now, again, you typically in a web page you don't have to have it formatted correctly. You can have it all in one string, and your web browser will interpret it pretty much the same way. But if you ever go to look at source code to troubleshoot anything, having it formatted correctly and indented and looking nice is pretty important. So this would be a great use of it. If you're building web pages, you could throw things like this into it and have it so it's putting it out nice. One thing I did want to point out, and actually we can see that in our others command shell. When you're doing it, you can format. If you notice here, I use the quotes. Here I use a single apostrophe to enclose my strings, a single apostrophe here. They're really interchangeable, unlike some other programming languages, Java. You can use either the quotes or the apostrophe. Again, this is going to know that when you're assigning this is the beginning of your string, and that's the end of your string. It's going to go from apostrophe to apostrophe. Now, if I had something in my string that was going to have an apostrophe, like, don't, the word don't has an apostrophe in it. If I know that word is going to be there, I may want to throw it in parentheses. Then I can use apostrophes within my, the string. If I want to use quotes, I'm quoting somebody, and then I would want to use the single apostrophe to show the beginning and ending of my string value. But again, here's just new lines. A bad creature does extremely fiendish growls. So A, B, C, D, E, F, G, and we're putting a new line in between each one of the words. Numbers and operators. So integers are simple whole numbers. If you've gotten this far, you have done math, and I assume you know what a whole number is. Basically, any number that doesn't have a period decimal point after it. Floats are a number with fractions. Any number that has a decimal point, even if it's a 0.0. So in a float, you'd have 2.0. In an integer, it would just be a 2. So here I'm assigning two integers, AB equals 2, 4. I want to point out that a difference between Python versions 2 and 3, and basically that was your integer division. In Python 2, integer division of two integers would yield an integer. So 13 divided by 6 would equal 2. In Python 3, division of two integers equals a float. Even if it was 12 divided by 6, it would be 2.0. 13 divided by 6 equals 2.1666. If you want to do integer division, basically get whole numbers only, you would do a double slash, 2 slashes, and you would have 13 divided by 6. Just basically to put 2 slashes in there. And that comes up with your integer division. But in 2, it's automatic. If you pass it 2 integers, you would automatically get an integer. That changed between 2 and 3. And I'm saying this because you're going to find this kind of stuff if you get working with old 2.7 code. And there's a lot of it out there. If you get working with that, you should be aware of those kind of changes and nuances between 2 and 3. Math operators is a plus, minus, star, multiply, slash, divide. 2 stars is the power. So a to the power of b. Complex math can be done with the parentheses, same as any other programming language. Multiple variables assignments, we did it before, but here's again, ABC equals 10, 20, 30. You can even do it with functions, like for instance, we're using a string with a split function, and you can do def equals this is fun.split, and if you type in d, you'll get this, e is, and f is fun. That is different, again. That's different than doing a d equals this is fun.split. A d equals this is fun.split basically makes d a list. It's a list of words, okay? And you can see it's displayed as a list when I go to display it. That's very different than doing, d is this, e is. This is actually passing the 3 words to 3 variables. This is passing these 3 words into a list of words. Okay, just want to point that out again. We'll be talking with lists a little bit in the next chapter. Wanted to make sure you were clear on that. Comments. Okay, now I've taken somebody else's shell to teach this class. They did a great job, put a lot of work into it. I haven't looked at all of it, and this is one area that I did not look at is what they require for comments. But this is my recommendation of what should be in every single any file that you create with the .py should have at least these 4 things on top. The first thing should be the version. Is this written for Python 3 and not Python 3.6? You could put in there in the comments for Python 3.6 and above, especially if you're using the F format function. That would be good to know in your first comment there. In this case, with this pound exclamation mark user bin local Python, if I call this file on a Linux machine, it's going to look for this path. And if the Python 3 is installed at this path, it's going to run the file. It's going to know which program to use to run this file. It's kind of like Windows does with extensions, right? Windows, if you have a .pdf extension, it knows to use Adobe Acrobat to open this PDF file. Same thing on Linux. If you tell it right here, use this Python 3, then it's going to know to look at the user bin local Python 3, look for that program to run this file. You should always put a change date in there. It's always good to know how current this code is. You should put who is creating the code. In this case, I've just got Professor Breaker. You may want to include your website. You may want to include your email address. I would probably not do that, but I would include my website or my organization. If you have a GitHub account, you might want to include your GitHub account. If you are publishing your code to a GitHub account, be very conscientious of your commenting. There are employers that will, when you apply for a job, they'll go out and look at GitHub to see if they can find any code that you've got, especially if it's a job that's heavily depending on good coding. They'll go out and look at your code. And if it's terrible commenting, they know that there are employers that will take that highly into into the decision making of if they want to hire you or not. So again, especially if you're going to put code out on GitHub or any kind of public site, make sure that you have good comments in it. Functions and classes should have their purpose defined. For a function, you should also have any required arguments. So for instance, this function shows how to collect an unlimited number of arguments and display them. Arguments can be a combination of strings or numbers. Now, if the arguments have to be a string, you would put that in here. The argument has to be a string. Or the argument has to be a string, a number, and a decimal and a float. Or an integer and a float. So putting that in your comments is very important. Arguments should be a string, an integer, and a float. In that order. It's very important. It makes it a lot easier when you go to troubleshoot or if the next person comes along to look at the function or classes. Again, classes we'll get into later, and we'll talk about commenting those in more detail, but definitely for functions and classes. Commenting, saying, I'm going to print this out, and then just putting the print statement. That's what we're going to do just to get used to comments, but typically you're going to comment really complex code and every function and every class. Definitely every function, every class. If you ever turn into an assignment to me that doesn't have a function commented, I will take points off. Constant variables. Constant variables are variables that typically are created and they're signed and they're embedded in the code. You're not going to be collecting information from a user and then using that as a constant variable. That's seldom. That's just bad practice. Normally this would be something like pi. Pi is always going to be 3.14. So if you're going to use pi in your code for some reason, you would define a constant variable like pi equals 3.14 blah 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 blah, and you would use that whenever you want to use pi. Or you may work for the DMV and you have minimum age or minimum driving age or something like that is defined as 16. Or you may be making widgets for a game and you say, If they do certain things, you can increase the speed on these widgets, but there's a maximum speed for the widget. The widget can't go more than 402 pixels per millisecond or something like that. Okay, and these are often used when they're creating class objects, and again, we'll explain class objects later, but those are constant variables. Typically, you always uppercase. Always make them uppercase, and you assign them and you include them in your embedded code. I think that's everything in the chapter. If you have any questions, feel free to email me or call me or talk to me about that. Hopefully this has helped explain the Chapter 2 of Python Crash Course.